Okay. So welcome to ReARM community meeting. That's actually first ReARM community meeting, and it's dedicated to agentic coding guardrails. I'll start with the short presentation on the agentic coding in general and on what ReARM can do here. So let me share my screen. Let me just rearrange a little bit. Okay. Can somebody let me know if you can see my screen, everybody, or is there
Yes,
an
you're
issue?
good.
Okay, perfect. Okay, so we'll talk about agentic coding guardrails, and to start with this. Okay. So this is a blog post by Simon Willison, which is fairly popular in the community. Maybe you have seen that, but this is something I want to start it with. So he named a concept that's called the lethal trifecta. And essentially, if all those circles match, then from the perspective of agentic control, then we have a big problem. By the way, I'll share the slides, and I have like the references here at the bottom of the slides. So let's discuss this circles a little bit. So first of all, access to private data. So if agent has access to private data, that's already kind of part of the issue. Second is ability to externally communicate. So to send something usually to the internet, to random websites. Note that the websites may not be very random, so we'll discuss it in a second. And the third one is exposure to untrusted content. So now we're not talking today about like all agentic applications. We specifically talk about agentic coding. So when we talk about agentic coding, you pretty much always have this bottom two circles. Because untrusted content is, so if you're doing developer work, there are frequently various extensions, dependencies, some third-party tools that you use. And that agent can actually pull from the internet sometimes on its own. So you see here, again, we go to ability to externally communicate. So it's...
Pavel?
Yeah, go ahead.
There is an interruption. Can everybody go on mute if you don't mind?
Yes, that sure.
I see somebody is still speaking.
Okay. Let me
If you could mute all of us and then.
Okay, let me, yeah, just a second.
Okay, drafts, yeah. Okay, I didn't follow it.
I'm just trying to. Okay, I think it's fine now. Thank you for that. Sorry for interruption. And yeah, so back to the slide. Essentially, the point I was making is when we're doing agentic coding, it always has exposure to untrusted content, and it always has ability to externally communicate. So there are tools that are kind of going against this, like trying to limit specifically this part or this part. Like basically they would say, okay, don't download this or don't connect to this website. It's malicious. However, recognize that it's possible to, for example, exfiltrate data to something like GitHub. And usually it's not the website that you can block. So there are limits that what you can do around these two circles in most scenarios. So this is just like a part of life. I would say the thing that we can control is access to private data. Like I have a blog post about that. And so essentially, whenever you work with agentic coding, one of the most important things is to make sure that the agent does not have access to any private data. And like classical attack scenarios that we've seen through, for example, supply chain attack, when agent would download something, some malicious dependency from the internet, if that is running on developer machine, then this dependency can then find, I don't know, AWS credentials or some crypto tokens or any private data you may have on your machine, and then essentially exfiltrate or act maliciously on that data. So the main point that we can control in terms of agentic coding is actually this one that should be separated from the agent. So this is the kind of first important point that I want to make here. The next slide, and again, I want to be sort of mindful of time here, and there is like a big OWASP resource that that I linked here, is OWASP Top 10 for agentic applications for 2026. And there are few other, so there is another OWASP Top 10 for LLMs, which is not there, but it's kind of less less interesting in this sense, specifically to what agents is doing. So you can see the top one is actually agent goal hijack. And the mechanism for that may be prompt injection, which is again, the main OWASP risk for LLM. And the goal hijacking essentially makes your agent do something that you didn't intend to do. And again, it's very difficult to control. Like we can go through other stages as well, like tool misuse, identity privilege, supply chain. A lot of them are interrelated, and you even have the one that says cascading failures. That is sort of relates to all of those things. But again, the point of this slide is like I'm not trying to make today's meeting all about this top 10. The point is when we are doing agentic applications, and coding is particular, although this is wider than coding, a lot of things at a lot of points can go wrong. And it is actually first difficult to keep them all in mind and sort of protect them. And the second issue that a lot of defenses that we see are around parsing the input, like what are your prompts, checking what the prompt is, what the agent reasoning is. And this is like text on text. And the problem with that is so far from basically from the research I read and I listened, so far researchers were always able to find some text that would sort of still exploit the previous text, if that makes sense. So in other words, there are no foolproof defenses on that side. And if the information or the data we're trying to protect is sufficiently important, then again, back to my previous point, the main guardrail is just make sure the agent never sees that data, that it never gets to it. Then you can have sufficient confidence that nothing bad will happen. But if agent somehow does have access to your personal data, then it's always at risk. That's the situation for 2026. We'll see how it will develop. Again, going specifically about agentic coding, let's discuss impact and blast radius. So the first is individual dev machine. And by the way, I'll talk about it a little later. These days, I don't even recommend coding on development machines, but we'll discuss it in a little bit. But let's say we start with individual development machine. So from security perspective, I would say this is pretty much hopeless because of all the attack vectors that exist. It's enough for an agent to download one malicious dependency or some little thing going wrong to compromise this machine and environment. And the larger your organization is, the higher the chances that this would happen. So the good news is if the system is built correctly, then this type of compromise can still be contained within one development machine. What can be worse, essentially, if this may lead to company-wide supply chain compromise. If, let's say, something bad happened on development machine, and then this poisoned the actual source code or actual applications that go through supply chain, and then suddenly this becomes to propagate to a lot of developer machines, developer environments, this is a much bigger problem. And the worst that can happen if this trickles into production instance. Again, I'm not I'm absolutely against running coding related or deployment related, development related agents on production instances. But the attack here we're talking about is something that may start with the individual developer machine, then proliferates into CI/CD pipeline, and then goes into production. So that's sort of like the worst case scenario that we're trying to avoid at all costs here. And here is basically where guardrails come. So the main guardrail of today is sandboxes. So again, I mentioned that like I personally do very little to zero coding these days on my developer machine. And I work almost exclusively in sandboxes. And this is basically how I recommend people doing it. One issue, though, about sandboxes is there are different types of sandboxes with different isolation. So sandboxes can be like a Docker image, it can be a virtual machine, it can be like within environments, let's say Python virtual environment, people may consider it a sandbox. So what I prefer using, although there are options, are essentially virtual machines in the cloud with some cheap hosting that have agents working on there, and they're not connected to any other environment within the organization. I think this provides sufficiently good protection. If, let's say, you split your own developer machine into sandboxes, this is much better than nothing, but still there are ways how something malicious can escape out of that. So, and by the way, this list is built on this very nice security guide from GitHub, which I also linked here. So the next thing that's discussed there is kill switches. I believe that sandboxes, so kill switch is the ability to shut agent down, shut down operation if you see something bad happens. I believe that in most cases, sandboxes actually have this, like provide this property nicely on their own. So for example, if you have sandbox as your VM on the cloud, then you just shut down this VM. And this may work as your kill switch. Then there are things that I discussed briefly, and there's like a lot of work, and there are solutions in those spaces is about input sanitization and validation. agentic harnesses are also doing that work. For example, if you're working with Claude or other harnesses, they may, on developer machine, they may ask you, do you approve this operation? Like, would you proceed? So this is also, I mean, I'm not saying it's the best way, but it's type of validation. There are also tools that would check every prompt and like reasoning that agent goes through. And if they see something potentially malicious, like let's say they see some password or some credential in there, they would block the execution. So this controls, I would say, are good defense in depth. But as I mentioned before, it's actually, they are not foolproof. It's all because it's text on text. It's always possible for a threat actor, for an attacker, to figure out something that would circumvent. So the next big piece, and this is what we do in ReARM, both in Community Edition and in Pro version, is observability. So observability is basically answering the question, okay, which code is written by agents, and what code is attributed to agents, and what did they write? This is actually sometimes surprisingly difficult question. And this visibility is already frequently useful in terms to understand whether something can go through or not. Like, remember here, now we're talking basically about this boundary when we're going from individual developer machine to company-wide supply chain. So we want to make sure, okay, what was created here and what goes into the general supply chain, and how do we prevent anything that shouldn't be there, essentially. And the second thing around the same boundary is approval boundary. So how you approve agentic code, and that's the capability that we have in ReARM Pro. So again, if this list is, especially the sandboxes part and the approval boundaries part, if this list is implemented, then you can have fairly good confidence about in general, about the agentic code that you have. Okay, so this slide about now specifically about ReARM, what changes we are going to do in the next release, but let me show you quickly how it actually looks like in terms of coding. So this is our development instance and the test we did like a while ago. And essentially, you can see that ReARM provides a specific contract for the agent, that for every agent, every time it does the work, it needs to create this session. So in every session, it has, like, we force it to create this report. First, orientation report, where basically it tells, okay, this is the task that the agent needs to do. And then the final report, where it said what was done and what was not done, what's completed. Then any commit that's made within the session is specifically attributed to a specific agent. So in this case, so this release was rejected. I'll show why soon, but the point I want to display here is this specific commit is verified against the agent that made this commit. And if we go to GitHub, you see it has, so first of all, it has this agentic trailers, and then this commit is actually signed by the agent. GitHub shows unverified because GitHub does not know the signature or the agent. But the agent would register its key cryptographically on ReARM. And with this, ReARM can say, okay, this commit is verified, and it's attributed to this specific agent and to this specific session. So this is essentially how we know that specific commit was done by specific agent. And next, now that we know it, we can apply policies on what agent did. And in this case, the policy is fairly simple. It just we say, okay, if there are high or critical vulnerabilities detected, then we would block this release and we would reject it. And you see the status is now rejected based on essentially these policies. And what it means is that any downstream processing, like any CI or CD, would ignore this release and treat it as not compliant. Same thing can be done like I showed you. So for example, I showed you this reports, agentic reports. So what happens if agent doesn't send those reports? Same thing, we create a policy orientation report required. And if there would be no orientation report, then we would just block any release that originates. Therefore, the agent itself won't be able to circumvent this policy or go through. Essentially, anything that happens downstream from there would just reject the release. And that's sort of the key idea of guardrails, is that we need to install deterministic process on top of what agents are doing, because agents may try to circumvent essentially anything, but those deterministic controls that are outside of the agents themselves, that they don't see it and they don't control it, this is what holds the thing together. And this is essentially how this approval boundaries guardrails work. Okay, so with that, I'll just describe briefly what goes on into our ReARM July release that's coming soon. So we're doing a lot of work on notification system. There'll be different notification channels and possibility for different people to subscribe. For example, Slack messages or team messages, and only some notifications may go in. We're adding concept of product and component teams into ReARM. So this is a little bit like internal developer portal functionality. So for every component or product, you would be able to see who is the leader, who are developers, etc. of this product. We're adding integration for known exploited vulnerabilities that are published by CISA or VulnCheck, and we're at the European agency. We will add it soon. By the way, this is needed for medical devices. There were questions about it, and we're also so we have a very heavy integration with dependency track. We're adding a lot of work on optimizing this, and at the same time preparing for version 5 of dependency track, which is released, and we'll be updating our integration. Also here, I want to mention that we're planning to open source our Helm chart, how we deploy dependency track, which would much simplify the deployment of open source version of ReARM plus dependency track. So we hope to have like less friction in there. We received some suggestions how to harden keycloak and ReARM actions. So that work largely has been done, and it's just pending the release in 1 or 2 weeks. And we are adding hardware bill of materials support. This is mostly explored in Pro version, and it has medical devices and defense applications mostly at the moment. Things that we are continuing to work against, they are mentioned in our repository, is full attestations workflow. We also want ReARM to do attestations. With that, it would be possible to verify things cryptographically outside ReARM, just using attestations. So I'm involved in this OWASP Transparency Exchange API work. I have a few talks on that if you want to research that. But essentially, this is API how we would exchange security artifacts, bills of materials, etc. And we're hoping to have full API completed first later this year. And about the same time, we should have ReARM also implementing this API. Finally, we're planning to add metrics into ReARM. For example, like lead times, how long does it take to resolve specific vulnerability? So DORA is a DevOps term. We're kind of aligning it to cybersecurity, and this is something that we're planning to do soon. Finally, announcement, I'll be at Black Hat, which is major cybersecurity conference in the US. So I'll be demoing ReARM Community Edition on August 6th at 11:20 a.m. That would be in Las Vegas. So if you're there, then I'll be happy to meet in person. Just let me know. Okay, and that's it. So these are the websites. By the way, the new website of ReARM going up hopefully tomorrow. And this is the Git repository. These slides I will try to put on the same repository later today, like the link to them. And with this, this is actually it. This is what I wanted to share. Thank you very much for staying on. If there are any questions, I'll be happy to or thoughts, I'll be happy to take them. And feel free to unmute yourself and ask if you have any.
No, Pavel, thank you very much for doing the presentation. One question of just a basic understanding of ReARM. How does it integrate, or what does it integrate with to do what it does?
Yeah, so ReARM integrates mainly it integrates at the CI level. So every time you have a CI build, the metadata and security artifacts, they are streamed into ReARM. And this, so you set it up once, and then it happens continuously for all your components. So every build you get like all the security posture metadata, etc. And it like ReARM automatically computes you like this vulnerabilities, checks things against policy violations, and things like that. Now, one more, like regarding agentic operations, we also added specific agentic protocols where agent call ReARM directly for certain operations via CLI. So those operations would be like initiate a session, create reports, which I was just showing, like orientation reports or final reports. And as I mentioned, what happens if, let's say, agent skips it and doesn't create it, you can just set up a policy that you would invalidate any work done by such agent. So agent essentially knows that it sort of has to follow all these procedures that you set up, because if it doesn't do, then releases or everything would be rejected. Does it answer the question, or like?
Yeah, I get it in the CI level. I'm just wondering, like, where I work, we use Jenkins. I don't know, would it connect in through that?
Yeah, absolutely. So for Jenkins specifically, we have a plugin. I mean, you don't have to use plugin. There is like CLI, but there is a plugin that you can install on your Jenkins, and it will. I can actually. I think it's if you go to our documentation. So our main site is. Let me put it in chat. It was on the slides also, but. Oh, 1 second. And then documentations are here. So you can find specific section for Jenkins, and yeah, you can use a plugin, or you can use just plain CLI, and it will connect. And by the way, you can this is for everybody. You can always connect with me after, like on LinkedIn or something, and I'll be happy to kind of show in more details how it works. So Anna, you have your hand up.
Yeah, so first of all, do you mind sharing the repo, the GitHub repo story here in the chat too? I couldn't
Yeah,
before.
sure.
So this agentic thing is kind of new to me a little bit. So coming here was actually to learn it. You mentioned before not sharing credentials and private data, which obviously is not something we want to do. But I thought that when you work with agentic, people always mention things like, you have your trip being booked, right, by an agent, and things doing in the background that you don't even are aware of, right? So I just couldn't understand when you said about not sharing that information, the agent should not have access to that. In what in what sense exactly? And like when it comes to ReARM, are you saying like ReARM, this agentic coding should not have access to any of that? So in what sense you don't share that, given that agents can do things to you using your personal data? Does my question make sense? Sorry if it's a little bit.
I'll try to answer, and then you tell me if it follows the direction you meant or not. Okay, let's do this.
Okay.
So first of all, this this part was not specific to ReARM that I mentioned, that agents should not have access to personal data. This was general thing that I believe is crucially important, and not only I believe. The second thing, like the point I was making, so I believe the only way to make sure that and remember, we're talking here about coding agents. We're not talking about agents who, I don't know, read your emails or things like that, which is like completely different story. We're talking about agents who write code. And I believe the ideal construct, how to make sure that those agents don't do harm, is to make sure they don't reach your personal data. And the point is, when you write code, usually you don't need, normally you don't need to share any personal or client personal data with agents. So this was the point that I was making. And for that, the sort of traditional solution is sandboxes. So essentially, if you create a sandbox, like a VM, bare VM in the cloud, you put your code in it, you put tools in it, you put agent in it. It has no data, like no personal data. Then it is good, because anything agent does over there, it just cannot reach your data. So the idea is that you should make a scenario where your data is essentially out of reach. And this is like the it may be sometimes misunderstood, but this is very important. So a lot of supply chain attacks that we saw recently, they had like somewhat different initial vectors, but basically the point is that something happens on developer machine. So let's say you have a compromised agent on your developer machine. But if, let's say, on the same machine you have credentials for AWS, I don't know, Kubernetes cluster, then this malicious agent or dependency or something can steal that credential and give. So this is the personal data that's leaked, and give to attackers, and then attacker can do anything they want with that. Or if they control the agent, they can from your machine do malicious things on these resources. So the point I'm making is make sure agents are isolated from this assets. This is the only guarantee that they don't use them, essentially. So this is anecdotally, but my own practice is, so I'm doing this sandbox, as I mentioned, like when we develop like ReARM and stuff. So the way this works is, for example, we have like a Kubernetes cluster so I put the Kubernetes cluster on the sandbox, and it deploys ReARM on that cluster. It does have so it has only test data from that sandbox. So about once a week or once every 2 weeks, what happens is agent changes credential, like the main keycloak password, to something like 12345, and puts me in the chat, or I made a mistake. I changed credential to something that's very kind of easy to bypass, etc. So it's not even something malicious. It was not taken over by any attacker or something. It tried to do some task. It couldn't. It thought it needed to change credential. It did, and then it compromised the system. So this is like a preview of what you get if you just let those agents run outside of sandbox into something important. And again, maybe in, I don't know, in a year or two, maybe this would not be like that much of a deal as it is right now. But currently, this is like the situation of the day. And I believe so the first thing is sandbox, plus make sure they don't really have access to that data. And so I hope that, so let me know if that kind of answers what you wanted to ask, or is it?
I think for an environment of agents that create coding, yeah, it makes sense for sure. Yeah. Thank you.
I think I would throw in that I thought, Anna, that was a fantastic question. And the reason being, you're looking at it from the runtime point of view, whereas Pavel's mainly talking about from the code time point of view, right?
Yeah, so I think, yeah, if you're talking about runtime agents and agents doing stuff outside of coding, that's like a much larger can of worms that is a little bit out of scope of this meeting. And yeah, there are like different opinions on that. I would like, the only thing that I can say from my perspective is, for DevOps, like DevSec, like any programming related, I would very much like to have no agents touching production environment directly. And we've seen, I don't know if, so there was a post by some founder recently where it deleted, like the agent deleted production database, and the founder blamed like, I think Anthropic, or I don't remember who. So he blamed essentially the cloud provider and blamed the creator of of the model. Although the root cause was basically letting those agents into this environment in the first place. So yeah, so basically those questions are kind of totally different can of worms that I kind of don't want to touch right now. They are a little bit out of scope of this meeting.
I just put it in the chat for you guys because I just asked that question in Copilot. I just randomly picked one of my open LLMs and it gave like 8 ideas, and which I think are worth exploring.
Sounds great. Sounds great. Okay. Any more questions or thoughts? Like it doesn't have to be like specific questions, but if there are more thoughts or things to bring in, then let's discuss.
I've got another question for you.
Sure.
So, like most companies, big companies looking at doing work in the cloud, where I work, they're using 2 out of the 3 big cloud providers. Do you have any recommendations there? Do you guys work with them or?
Regarding cloud providers specifically?
Yeah, like I'm talking like, the big 3, Microsoft, AWS, GCP.
Yeah, so yeah, thank you for a question. So I mean, I'm in like working in this field for, I don't know, 15 years, I think. So basically my philosophy always with the clouds was possibly because early in the career I had to move from one to another frequently. And I kind of wanted to optimize for that. So from every cloud, I only try to use features that are the same between the clouds. And then with this, I'm not getting locked into any of them. And with that, they all become kind of pretty much the same. Essentially, so what happens is when you lock yourself up to one, so you start using something that only is present, I don't know, on AWS, then your move to another cloud becomes difficult. So this is something I usually prefer to avoid because then they have like leverage on you. But as long as you avoid it, and the easiest way is just use, like I would say, use, I don't know, Kubernetes S3, like the proven technology, which is easily replicable between different clouds, then I would say they are all kind of about the same. Also for development, so I was mentioning the sandboxes in the cloud, right? So for this, you don't even need to use the major cloud. You can use some discounted providers like OVH Cloud, Hetzner. There is like a new player, can't remember the name right now. Like there is European, I think it's called NetCup or something, which is very, very cheap. So for this specific sandboxes, you can use this low cost providers, and this yeah, there is DigitalOcean as well, and this would be cheaper. For real work, it's usually like if you're doing any kind of regulatory work, then it's AWS or Azure in the US, because they have like this GovCloud providers. In Canada also, it's I think it's mostly Azure from what I know. So if you're doing government work, then you have restrictions based on that. But outside of it, I'd say it's pretty much the same. Like I have my preferences, but none of them are too serious at this point.
Okay, great. And then does ReARM, do you use that with any of those cloud providers?
Yes, absolutely. There is zero dependency. So the way how so ReARM always, we decided not to do kind of SaaS structure. ReARM is always individually deployed. So even if you use open source, or if you buy a pro version from us, so open source, you obviously you self-host. Pro version, we can host it for you, but it will be only your instance. Or you can host it on your own infrastructure and buy a license from us. So we don't mix clients on the same infrastructure. So everything is single tenant essentially. And it can, so essentially what you need is like the base requirement is Kubernetes cluster or OpenShift cluster. And this can work on any cloud, essentially.
Great, thank you.
Okay, we're 3 minutes, basically. I think it's good timing, so we're almost up. If there are no more questions, I just want to thank everyone for joining today and participating. It was my pleasure, and I hope it was useful and interesting. So as you saw, I posted my LinkedIn above, so feel free to connect. I'm happy to discuss ReARM outside of this meeting. If there is desire, just message me and we'll kind of figure out time. If you're at Black Hat, as I mentioned, I'll be happy to see you at my demo, or again, we can meet outside. I will try to, for meetup, I will try to schedule next meetings. I cannot give you the date, but probably would be something around end of August. That's what I think. Also, for meetup specifically, if you have ideas in terms of topics that you want to discuss, it doesn't have to be related to ReARM or agentic coding. So basically anything regarding AI ML, if you have suggestions about topics or you would like to present, then just message me through LinkedIn or Meetup and we'll try to organize this. For today, I think that's it. Yeah, and as I mentioned, I will put the link to the slides in our GitHub repository, so you can take it from there. Thank you very much for participating, and that would be all for today. Thank you.